Hello everyone, welcome to the lecture again. In the last class, we derived the expression for the rope or belt friction. We also look at couple of examples. Today, we are going to continue the discussion on the rope or belt friction and we are going to look at some more examples on the same concept. So, let me write down the first problem statement. A rope ABCD is looped over two pipes as shown. Knowing that the coefficient of static friction is 0.25, determine A, the smallest value of the mass m for which equilibrium is possible. And B, the corresponding tension in portion BC of the rope. In this problem statement, we have been asked to find out the smallest value of mass m and also the corresponding tension in BC. So, first of all, for the smallest value of mass m, the impending motion of the 50 kg mass will be downward. So, let us look at the situation for the smallest value of mass m, and let us look at what happens with pipe C. Okay. Now, since the impending motion of the 50 kg mass is downward, therefore, the tension in BC part will be more than CD, therefore, this can be taken as T2 and this can be taken as T1. Okay. So, T2 will be T BC and T1 will be M times G for this pipe. Therefore, you can see that T2, which is TBC, equal to T1 e to the power mu times beta. Mu is given, it is 0.25 and you have to see how much angle this rope is making on pipe C. So, if the rope would have been like that, then it would have been 90 degree, but since this angle is 30 degree, therefore, the rope is making an angle of 90 minus 30 degree, which is 60 degree, and it can be written as pi by 3. Okay. So, therefore, you have to multiply it by pi by 3 or we get TBC over mg, because T1 is nothing but mg, equal to e to the power pi by 12. Let us call it equation number 1. Now, let us look at pipe B. For this, we have this tension to be larger than TBC. So, therefore, T2 will be 50 kg. So, 50 into G and T1 will be TBC. Therefore, we have T2 equal to T1 e to the power mu into beta. Now, in this case, the total angle is 90 plus 30 degree. So, 90 plus 30 degree, which is 120 degree, and that is equal to 2 pi by 3. So, into 2 pi by 3, therefore, I can write down 50 G over TBC equal to e to the power pi by 6. Let us call it equation number 2, and since we want to calculate m, therefore, let us multiply equation number 1 and 2 so that TBC will get away. So, TBC over mg into 50g over TBC. So, we are just doing 1 into 2 equal to e to the power pi by 12 plus pi by 6. Therefore, we will get m equal to 22.8 kg. Now, to find out the tension T, you can use equation number 1 and you can put the value of m. So, for part B, this is for tension in BC. Let us use equation number 1. So, we get T BC equal to mg into e to the power pi by 12, m is 22.8 and g is 9.81. So, you get 291 Newton. Let us look at one more problem on the similar concept, and the problem statement is following. Determine the range of mass m over which the system is in equilibrium A if the coefficient of static friction is 0.20 at all 3 fixed shafts, and B if the coefficient of static friction associated with shaft B is increased to 0.50. So, again the concept is same. Let us look at part A. So, you have 3 shaft, this mass is m, you have one shaft here, one shaft there and one shaft here. This is A, B and C, and here I have 2 kg mass. So, we have to find out what is the range of masses over which this will remain in equilibrium. So, again let us say that first the impending motion is towards m, we will consider the other case later. So, let us first think as if the impending motion is towards, let us say, m. So, if the impending motion is like that, in that case this will be our T2. Okay. So, we will have T2 equal to T1 e to the power mu beta, and T2 will be T1, T1 is 2 kg into e to the power mu, mu is given, it is 0.2 for all the shaft. So, 0.2 into beta. Now, we have to see how much overall angle it is making. So, here it is a pi angle plus pi angle plus pi angle. So, it is 3 pi angle. Okay. Therefore, T2 will become 2 into e to the power 0.6 pi, and this gives you T2 equal to 13.17 kg. So, this is one range for which the mass m is going to go downward. Now, let us look at the second case wherein we assume that the impending motion is towards 2 kg. In that case 2 kg will be your T2. So, again we have T2 equal to T1 e to the power mu beta, but now T2 will be 2 kg. So, 2 equal to T1 e to the power mu is 0.2 and beta is pi plus pi plus pi, which is 3 pi. So, from here we get T1 equal to 2 over e to the power 0.6 pi, which is 6.58, and this gives you 0.304 kg. Therefore, the ranges for mass m for which it will be in equilibrium is m should be less than equal to 13.17 kg and it should be larger than equal to 0.304 kg. Now, in part B, it has been asked to again find out the range of masses for which the equilibrium is there, but now the static friction associated with shaft B has been increased to 0.5. The friction with shaft A and C, it remains 0.2. Okay. So, let us look at part B. Again, let us say that the impending motion is towards m first. So, therefore, we will have T2 equal to T1 e to the power total mu beta. So, let us say it is mu 1 beta 1 plus mu 2 beta 2. Okay. So, T2 will be mg. So, it will be T2 equal to T1 is 2 into e to the power mu 1. So, for A and C, let me write down the combined way. So, it is 0.2 into total beta is pi plus pi, which is 2 pi, and then we have e to the power mu 2 is 0.5 and beta 2 is pi. Okay. So, this gives you T2 equal to 2 into e to the power 0.9 pi, or T2 will be 33.8 kg. Now, for the impending motion, towards let us say 2 kg. So, in this case we have again T2 equal to T1 e to the power mu 1 beta 1 plus mu 2 beta 2, but now this T2 will be 2 kg. So, 2 into equal to T1 e to the power again 0.9 pi, or T1 will be 2 over e to the power 0.9 pi equal to 0.118 kg. Therefore, the range of masses will now be less than equal to 33.8 kg and it should be greater than equal to 0.118 kg. Okay. Now, let us look at couple of example of the belt friction. So, let me write down the first problem statement, and it is following. A flat belt is used to transmit a couple from drum B to drum A knowing that the coefficient of static friction is 0.40 and that the allowable belt tension is 450 Newton. Determine the largest couple that can be exerted on drum A. So, first let us see how much angle the belt is making with drum A and drum B. Let us call it beta A. So, beta A is the angle that the belt is making with drum A. So, you can see here it will be 180 degree plus 15 degree plus 15 degree. So, which is 7 pi by 6, and the angle that the belt is making with drum B will be 180 degree minus 15 degree minus 15 degree, that will be 5 pi by 6. So, here since the beta B is small than beta A, therefore, the slippage or the slipping will happen first on drum B. Therefore, let us calculate the tension in drum B. Okay. So, we use T2 equal to T1 e to the power mu beta B, and T2 is given, it is 450 equal to T1 e to the power mu, which is 0.4 into beta B equal to 5 pi by 6. This gives you T1 equal to 157.9 Newton. Now, in the problem statement, we have been asked to find out what is the couple on drum A. So, let us look at the free body diagram of drum A. So, we have this drum, this point is A, and we have tension T1 and tension T2, and since there is a connection over here, so therefore, this will also apply a force, let us say Ay in the y direction, and there will be a resistive moment. So, let us call it Ma. This is the free body diagram of the drum, and to find out what is the value of Ma, we can take the moment about A. Okay. So, let us take the moment about A. In this case, Ay will not contribute. So, we have Ma plus the tendency of T1 about point A is to rotate it in the anti-clockwise direction. So, it will be T1 into the perpendicular distance, which is the radius, and it is given, it is 120 mm. So, it will be 0.12 minus T2 into 0.12, and this should be equal to 0. Therefore, you get Ma equal to 0.12, 450 minus 157.9, because T1 is 157.9 and T2 is 450 Newton. Therefore, Ma will be 35 Newton meter. Now, let us look at one more problem on the similar concept. So, here the problem statement is following: a flat belt connects pulley A to pulley B. The coefficient of frictions are mu s equal to 0.25 and mu k equal to 0.20 between both pulleys and the belt. Knowing that the maximum allowable tension in the belt is 3 kilonewton, determine the largest torque that the belt exerts on pulley A. So, first let us see how much angle the flat belt is making with pulley A and pulley B. So, with pulley A, let us say the angle is beta A, and you can see that this angle is 180 plus 60 degree, which is 240 degree, and this I can write down as 4 pi by 3. Similarly, beta B will be 120 degree, and this is 2 pi by 3. Now, the radius of the pulley A is 8 inch, which can be written as 200 mm, and the radius of pulley B is 1 inch, which is 25 mm. So, again you can use the same concept, since beta B is less than beta A, therefore, the slippage or the slipping will impend first on B. Therefore, we have to analyze pulley B first and find out the corresponding tension. So, we have T2 equal to T1 e to the power mu beta B, and T2 is given, it is 3 kilonewton. So, let me just write down 3 kilonewton itself, equal to T1 e to the power mu is 0.25 into 2 pi by 3, and this gives you T1 equal to 1.777 kilonewton. Now, since we know what is T1 and T2, let us find out the moment on drum A, and for that let us look at the free body diagram of drum A. So, we have this drum, there is T2 and T1 force, and from pin A there will be a reaction force which will be in the direction which connects A and B. So, let us say it is like this R A, and there will be a moment to oppose the rotation, let us say it is some M A. So, now to find out what is the value of M A, let us take the moment about A. So, we have M A and R A will not contribute, plus 1.777 into the perpendicular distance. So, it is given that this is 200 mm. So, therefore, it is 0.2 meter into 0.2 equal to 3 kilonewton into 0.2, and this gives you M A equal to 0.245 kilonewton meter. So, with this let me stop here. See you in the next class. Thank you.